Hey everyone. So here begins part 2 of our time together. And part 2 is going to focus on sinusoidal and polynomial functions, okay? So what we've done is we've divided it into 3 sections. So there's going to be 3 separate videos. This will be video 5, 6, and 7 in your list. So video 5 will deal with polynomial characteristics, and video 6, applications of polynomials. And then video 7 will deal with sinusoidal characteristics and applications together in one. Okay, so what we're going to do today is we're going to get started with polynomial characteristics. Okay, all right, so a polynomial function is a function with many terms. That's literally what the name polynomial means. Poly means many, nomial means numbers. The terms are added or subtracted by each other. To be a polynomial function, the exponents on any given variable must be whole numbers, okay? So you can't have like x to the negative 2, okay? Now, you also have to remember that that means you can't have 1 over x squared, because x to the negative 2 and 1 over x squared mean the same thing. So when we say they have to be whole numbers, that rules out negative exponents and it rules out variables on the bottom of a fraction. If I had variables on the bottom of a fraction, I'd be rational, and we just spent the first few videos dealing with rational functions, okay? A polynomial that has 1 degree is a line, a polynomial of 2 degrees is a quadratic, and a polynomial of 3 degrees is a cubic. Now remember, you know that based on the exponent that you see. Okay, so if you don't see an exponent at all, like y equals 3x plus 5, that's a degree 1 polynomial, okay? The highest exponent you see on your x is a 1, because there's nothing there. As soon as you see an x squared, that's where you get a quadratic, that's where you get a degree 2. And then as soon as you see an x cubed, that's where you get a cubic. Now, the other thing you have to think about there is we name those degrees assuming that we've multiplied everything out. So for instance, if you saw something like this, y equals x times x plus 3, I would need you to look at that and say, hey, that is a degree 2 polynomial, because if I was to multiply all this out, I'd get x times x, and that would be an x squared, okay? Okay. The leading coefficient is the number at the beginning of the polynomial when written in order of descending power. So we always go highest exponent and we work our way down through the terms until we get to the lowest exponent, which would just be the number with no variable. If the leading coefficient is positive, the graph will end up, and if the leading coefficient is negative, the graph will end down. Okay, so positive leading coefficient, that's the front number, if it's written in the proper order, causes the graph to end going up, and negative causes the graph to end going down. The maximum number of x-intercepts a polynomial can have is the degree of the polynomial. So like for instance, a degree 3, I can get 3 x-intercepts out of that, okay? It might look like this. And I can see 1, 2, 3 x-intercepts there. Okay, now it's the maximum because I don't have to have 3 x-intercepts, okay? I could have just 2 x-intercepts. Like that, okay? Or I could have 1 x-intercept if I had it like that and it didn't actually hit the x-axis, okay? But what it's saying is there's no possible way to get 4 x-intercepts out of a degree 3, okay? The number of turning points in a polynomial is equal to 1 less than the degree of the polynomial. So if you look at this one, I see 2 turning points. Here I change direction, and here I change direction. So 2 turning points, that means I have to be a degree 3 polynomial because I always have 1 less number of turning points than the degree, okay? Okay, polynomials can be written in general form or factored form. General form was that form I was just describing, where we start from the highest exponent and work our way down to the number by itself, which by the way is called the constant term. Factored form looks like that red one I gave you there, y equals bracket x minus a and bracket x plus b. Okay, and each of those factors would tell you what x-intercepts you have. So the roots, or x-intercepts, can be solved algebraically by factoring. We could also do the quadratic formula, which we will review, by graphing or by regression, and we're going to do all 4 of those together, okay? The y-intercept is the constant term when written in general form. So if I took you up to this guy, the constant term would be that guy right there. Okay, it would be the number all by itself with no variable. I'm just going to hide myself for a sec so you can see where I circled. Okay, awesome. Okay, so let's take a look at a few questions together. Let me get that ink off for you. A graph of the polynomial function p of x is shown to the right. The equation of the polynomial can be represented as. Okay, so I need you to see here, I have two x-intercepts, one at A and one at B. I know that the one at B has to have a square on it, okay? When we see that square on a term, now these guys all have that square on it, but I just want to talk about this for a second. When we see that square on a factor, it means that I'm either going to hit the x-axis. Let me get a different color there so you can see that better. It means I'm going to hit the x-axis like this or like this, but essentially it means I'm going to be on the x-axis, okay? That turning point is on the x-axis. Okay, so there we go. So I see in this graph that I end down, okay? I end going down. So that means I need a negative leading coefficient. So that's actually going to rule out B and C. Okay. There we go. I needed that a little thicker. Okay. And then I need to look at this as x minus b squared and x plus b squared. Those are now kind of this distinguishing factors. And what happens is the b term right now is on the right. And that actually makes x minus b as a factor. Now, if you're worried about that or if that sounds confusing, let's just play with it for a second. If I said x minus 3 was a factor, okay, that would mean that x minus 3 equals 0. That's how we go to solve these things, right? Well, if x minus 3 equals 0 and I'm solving for x, I'd have to add 3 to both sides and x would equal 3. So a factor of x minus 3 gives me an x-intercept of positive 3, okay? And so for this very same reason, the fact that we see on this picture b is to the right, that means the factor must say x minus that b value, okay? So that gives us, oh, and then for the exact same conversation, let's just have the conversation around x plus a, okay? If this had said x plus 3, and I go to solve that, that would now be x equals negative 3 because I'd have to subtract 3 from both sides, okay? And so the x plus a tells me that the a is to the left, and the x minus b tells me that the b is to the right, okay? And so my answer is A. Okay, that gave me my negative leading coefficient, it gave me my A value is to the left, and it gave me my B value is to the right. Okay, the following statements were made about the polynomial function y equals x minus 5 squared times x plus 3. The statements that are true are what? So let's just go through each statement and decide whether they're true or whether they're false. So the x-intercepts are at negative 3 and 5. If I wanted an x-intercept, I would take this and set it equal to 0, and I would take that and set it equal to 0. And yes, that does give me x-intercepts of negative 3 and 5. Okay, the function has a degree of 3. Now remember, the degree is figured out by the highest exponent you see, assuming you've multiplied everything together. Okay, so if I was to multiply this out, I would end up, this would be an x squared at some point, right? When I multiply all that out, and I'd get an x squared times an x. So that would give me an x cubed, which means yes, the function does have a degree of 3. The domain is negative 3 is less than or equal to x is less than or equal to 5. That is not true. The domain of all polynomial functions is x is a member of the reals. Okay. The range is y is member of the reals. Well, you could graph this and just get an idea of what it looks like. I know I have an x-intercept at 5. I know I have an x-intercept at negative 3. And I know it looks something like this. Okay, and so And again, if you weren't sure of that, that's okay. You could just plop it in your graphing calculator and get a picture of it, okay? But yes, the range is a member of the reals because this is going to go down to negative infinity and go up to positive infinity, okay? So 1, 2, and 4 are all true, okay? So that is C, okay? Okay, the function f of x equals x squared times 3 minus x is a polynomial of degree blank that ends blank. The correct order of the blanks is. Okay, so you got to be careful with this guy because this is not written in a friendly manner. The first thing you're going to want to do is get rid of the brackets, either in your head or on paper, and you're going to rewrite that. So that's f of x equals, okay, my very first term is actually going to be negative x cubed. Okay, and that is actually this guy, but the reason I wrote it first is because I knew that that would have a higher degree than the second term. Okay, so then the x squared times 3 is what I haven't done yet, and that would give me the plus 3x squared. Okay, so this is the degree 3, and I have a negative leading coefficient. Okay, I'm just going to turn myself off there so you can see what I wrote. I have a negative leading coefficient there, and that means I'm going to end down. So it's a degree 3 and I end down, and so the answer would be D. Okay. All right, given the scatter plot to the right, the best word to describe this relationship between the dots. Well, if I go to connect the dots, what sort of thing am I looking at? Am I looking at a line? Am I looking at a quadratic? Or am I looking at a cubic? Quartic, nobody ever talked to you about quartic, so that one I'm pretty sure you know is not one of the solutions. And hopefully you see that that is a quadratic, but just for clarification, linear would be a straight line, okay? A quadratic is a parabola, and a cubic looks like that, okay? So for this guy, yes, the answer is a quadratic, okay? All right, so solve by factoring. Now, we have been factoring in other ones. We've done lots of factoring with rationals, so hopefully this is going to feel okay. Remember, actually, one of the biggest mistakes I see 30-2 kids make is they go and they immediately say, okay, I need to find two numbers that multiply together to give me -3 and add together to give me -2. That is not the case here because you don't go factoring unless it equals 0. Everything has to be on one side, and it has to be equal to 0. So the first thing I need to do here is subtract 5 from both sides. When I do that, I end up with x squared minus 2x minus 8 equals 0. Okay, so now I'm looking for two numbers that multiply together to give you -8 and add together to give you -2. Those numbers are -6 and 4. Sorry, those numbers are -4 and 2. 6 times 4 is 24. I don't know what I was thinking there. So those numbers are -4 and 2. And now what happens is this concept of the zero product principle. Okay, so I have a number times a number equals 0. In order for that to be true, one of those numbers has to equal 0. So I split it into two conversations. I say, okay, that means either x minus 4 equals 0 or x plus 2 equals 0. Okay, that's where the zero product principle comes into play. So now if x minus 4 equals 0, then x equals 4. If x plus 2 equals 0, then x equals -2. So I have two possibilities, x equals -2 and x equals 4. Okay, so for this one, same sort of setup. I got to get rid of that 10 first because I can't use that zero product principle unless it equals 0. So I can't do factoring unless everything's been put on one side of the equal sign and I'm left with nothing on the other side. So I subtract 10 from both sides and that gives me 2x squared plus x minus 28. Now, this one's a little different because there is a coefficient on the x squared. Okay, so most of you probably have gone through a process in your life called decomposition, and that's what I'm going to show you here. You're looking for two numbers that multiply together to give you these outside numbers multiplied together. Okay, so 2 times -28 is -56. So two numbers that multiply together to give you -56 and add together to give you a 1. So you just go through your factors of 56. I have 1 times 56, that's not going to work. 2 times 28, 3 times nothing, 56 divided by 4 is 14, so 4 times 14, 5 times nothing, 6 times nothing, 7 times 8, there we go. Okay, that one works. And I just make my 7 be negative, okay? Negative 7 times 8 is negative 56, and negative 7 plus 8 is 1. So what happens is I'm going to break that middle guy into those two numbers. So I'm going to write 2x squared, and then either plus 8x minus 7x minus 28, or 2x squared minus 7x plus 8x minus 28. It doesn't matter the order that you put them in, okay? I chose to go plus 8x and minus 7x. Now I'm going to factor the front two and factor the back two. So I'm going to look at these two and look at these two kind of as separate questions. And I'm going to say, what can I take out of a 2x squared and an 8x? And that'd be a 2x. And then what can I take out of a negative 7x and a negative 28? If that front dude is negative, you always want to take out the negative, okay? So I'll take out a negative 7. Okay, so when I do that, I'm left with this. I took the 2x out of the front two, and I was left with x plus 4. And I took a negative 7x, or sorry, negative 7 out of the back two, and I'm left with x plus 4. Now, I have a common factor here of x plus 4. So the x plus 4 is common to both of these terms. I can pull it to the front, and then I'd be left with 2x minus 7 times the x plus 4. Okay, now I'm down to the zero product principle. So either 2x minus 7 equals 0, or x plus 4 equals 0. If 2x minus 7 equals 0, I add 7 to both sides, divide by 2, so x will equal 7 over 2. And if x plus 4 equals 0, I just subtract 4 from both sides, and I get x equals negative 4. Okay. All right, now the quadratic formula. The quadratic formula is on your formula sheet. It's not something you have to memorize. So I've put it right here for you. If you want to just quickly copy it down, it's x equals negative b plus or minus b squared, or the square root of b squared minus 4ac all over 2a. Okay, negative b plus or minus the square root of b squared minus 4ac all over 2a. When you're writing that, by the way, before I put myself back, just make sure that this square root goes all the way to the end to that c, that's important, and make sure that this fraction, this line here, covers the whole thing, okay? All right. So a is 1, b is 2, and c is negative 7. So I'm going to plug those numbers into the quadratic formula. So I have negative 2 plus or minus the square root of 4, that's b squared, right? 2 squared, minus 4 times 1 times negative 7, all over 2 times 1. This becomes 4 plus 28, so that'll be 32. And then I want to see if I can reduce it, okay? So 32 is 16 times 2. So I could bring that 16 out and have it be 4 root 2. This one actually asked you for the nearest hundredth as well. So at this point, you could, if they're asking you for the nearest hundredth, they're not looking for you to simplify this first. So at this point, you could also just go right to your calculator. Your two answers are going to be negative 2 plus root 32 all over 2 and negative 2 minus root 32 all over 2. Okay. And so that becomes negative 3.83 and 1.83. But just to finish the conversation I was having, just if you did have to simplify it, I'm looking at root 32 for a second, okay? And I'm saying, hey, that's 16 times 2. So I could write root 32 as root 16 times root 2, but then root 16 is 4. So I could simplify that to 4 root 2, okay? Either way, you'd get the same answers when rounding to the nearest hundredth. Make sure when you type that in your calculator, I'm just trying to troubleshoot thinking, what if you didn't get the answers that are below? What could have happened? let me just erase that for a second. Either you have to put all of this in a set of brackets before you divide by 2, or you're going to have to hit enter on your calculator and then go divide by 2. Okay, so if you're not getting my answers right now, that might have been the problem that you're having. Okay, all right, let's try another one. So solve this guy by the quadratic formula. So this time, this is A. So A is 2, B is 1. And we got to get this guy over here first, right? We got to add 3 to both sides. So that's actually going to be a -1. So C is -1. Okay. So I wrote that as equal to 0. Just like with factoring, you can't do the quadratic formula unless it equals 0. Okay. So then I have -1 plus or minus the square root of 1. 1 squared is 1. Minus 4 times 2 times -1. -4 times 2 is -8 times -1 is 8. So that becomes 1 plus 8, which is 9. Okay, so now I'm looking at the root of 9 is 3. So I'm looking at -1 plus 3 all over 4 and -1 minus 3 all over 4. Okay, so -1 plus 3 would be 2. 2 over 4 is a half. And -1 minus 3 would be -4. -4 divided by 4 is -1. So my two answers end up being -1 and 1/2. Okay. All right. Which of the following is most likely the graph of a cubic function? Well, when I look at all of these, you should actually be familiar with what each one of these looks like by now because you've taken the whole course. And so I'm hoping you're going to say right away the answer is B, but I want to have a little conversation here as well. This would be a quadratic. This would be a sinusoidal, and this would be an exponential. Okay. Just to make sure you can recognize all of those graphs. Okay, and so the answer would be B. Okay. Sketch a graph of a polynomial function that has 3 x-intercepts, a negative constant term, and a negative leading coefficient. Label a minimum of 3 points on your graph and determine the domain and range. Okay, so if I want 3 x-intercepts, that's fairly easy. A negative constant term, remember that the constant term is actually the y-intercept, okay? So that means I need to hit my y-axis somewhere below here. I also need a negative leading coefficient, which means I need to end going down, okay? So essentially, we could just pick the 3 x-intercepts we want, pick the negative y-intercept that we want, make sure the end to the right is going to go down, and then backtrack and see how it all comes together, okay? So I picked something like this, okay? So I picked -9 and 1 and 6 for my y-intercepts, sorry, my x-intercepts, -2 for my y-intercept, which is a negative constant term, and I made sure I ended down. Now, it also said to label a minimum of, I think it said 4 points. Let me just go back there for a second. No, 3 points. Label a minimum of 3 points. Well, that's easy. Those can just be my 3 x-intercepts, right? So -9, 0, 1, 0, 6, 0. And then I also threw in the y-intercept, which was 0, -2. A reminder, when you're asked to label points, points are coordinate pairs, so they have to be bracket x, y bracket. Okay? Okay, which graph represents a cubic function? Well, they all do. That's the first thing I want you to notice. Okay, with a negative leading coefficient and a positive constant term. So again, a negative leading coefficient means I'm going to end down. So right away, A ends up and B ends up. So those guys are gone. Then I need a positive constant term. The constant term is the y-intercept. So this guy has a negative y-intercept, so C is out. So it looks like the answer is going to have to be D, positive y-intercept and a negative leading coefficient. So that is it for polynomial characteristics. The next thing we'll do is start looking at some applications, and in applications we'll deal with regression as well, which we'll use in a few different scenarios along the way here. Okay, so we'll see you in a bit, whenever you want to see me, for applications of polynomials. Okay, take care, guys.